In today's video, we will be studying an application known as net change. What we will do in this video is just introduce what net change is, and then do several examples of calculating a net change. If we consider a function f of x over an interval a to b, the net change, which is delta f, is f of b minus f of a. However, by the fundamental theorem, this is the integral from a to b of f prime of x dx. So, if we're given a rate of change for a quantity, we can determine its net change over an interval. That is how much this quantity is changing over the interval. This is known as the net change theorem. And it says the net change in a function over an interval a to b, or I'm sorry, I want to use t1 to t2, is given by the integral from t1 to t2 s prime of t dt, and of course that is delta s. Let's now consider some examples. If the motor on a motorboat is started at t equals 0 hours and the boat consumes gasoline at the rate of 5 minus t cubed, measured in gallons per hour, how much gasoline is used within the first 2 hours? Well, we've given c prime. We're looking for the net change of c in the first 2 hours. So we're looking for the integral from 0 to 2 of 5 minus t cubed dt. And then, of course, we can calculate this using the fundamental theorem of calculus. Antiderivative is 5t minus t to the fourth over 4. Then we evaluate that from 0 to 2. We get 5 times 2 minus 2 to the fourth over 4 minus 5 times 0 minus 0 to the fourth over 4. This is 10 minus 4, which is 6 gallons. So in the first 2 hours, this motorboat has used 6 gallons of gasoline. Next, Andrew is an intermediate ice boater who can attain speeds equal to twice the wind speed. Suppose Andrew takes his ice boat out one morning when a light 5-mile-per-hour breeze has been blowing all morning. As Andrew gets his ice boat set up, though, the wind begins to pick up. During his first half hour of ice boating, the wind speed increases according to the function 20t plus 5. For the second half hour, the wind remains steady at 15 miles per hour. Assuming that he moves in a straight line away from his starting point, how far has he traveled after 1 hour? Right, so first we need our function. Let's call it v of t, and this is a piecewise function. It will be 20t plus 5 for the first half hour. Then it will be a straight 15 for the second half hour. What we're looking for is delta S, right? How far he's traveled. Well, this will be the integral from 0 to 1 of twice v of t, right? Because he can move at twice the wind speed. Now we have two integrals we have to consider. First goes from 0 to a half, and that'll be 20t plus 5. The second goes from a half to 1, and that'll be of just 15. Right, so the first integral is for the first half hour of his trip. Second integral represents the second half hour of his trip. Using fundamental theorem, we get 2 times 10t squared plus 5t. T goes from 0 to a half. Then for the second half hour, we get 2 times 15t. T goes from 1 half to 1. Evaluating that first, we get 2 times 10 times a half squared plus 5 times a half, then minus 2 times 10 times 0 squared plus 5 times 0. Now we want to add for that second one. Right, 2 times 15 is 30. Then we just have 1 minus a half. This will be 2 times 5 halves plus 5 halves. That second piece goes all to 0. 1 minus half is a half, so then minus 15. This becomes 5 plus 5. Hold on, something went horribly wrong. My apologies, this should have been a plus. Alright, so now it'll be 5 plus 5 plus 15, which winds up being 25 miles. Next, let's consider marginal cost of producing X computer chips, measured in units of 1,000, is given by C prime of X is 300X squared minus 4,000X plus 40,000, measured in dollars per 1,000 chips. We wish to first find the cost of increasing production from 10,000 to 15,000 chips, then determine the total cost of producing 15,000 chips, assuming it costs 30,000 to set up the manufacturing run. Right? First, look at A. We're looking for a net change. Right, so we're looking for change in cost. This is the integral from 10 to 15 of 300x squared minus 4,000x plus 40,000. We'll get 100x cubed minus 2,000x squared plus 40,000x evaluated 10 to 15. Right, because remember x is being measured in thousands of units. So we will have 100 times 15 cubed minus 2,000 times 15 squared plus 40,000 times 15, then minus 100 times 10 cubed minus 2,000 times 10 squared plus 40,000 times 10. And that evaluates out to $187,500. Now, for part B. Determine total cost of producing 15,000 chips. This is going to be 30,000 plus the integral from 0 to 15 of c prime of x, which was 300x squared minus 4,000x plus 40,000, right? This 30,000 represents the initial cost to set up, and then this represents the change in cost from 0 to 15, which is just how much it would cost to produce 15,000 chips. So it'd be 30,000 plus that 100x cubed minus, 2,000x squared plus 40,000x. Evaluate x is 0 to 15. And 30,000 plus 100 times 15 cubed minus 2,000 times 15 squared plus 40,000 times 15. I'm sorry, and then there should be a minus evaluated 0, but this should just go to 0 anyway. Right, 100 0 cubed minus 2,000 0 squared plus 40,000 times 0. This will wind up giving us $517,500. That not only concludes this video on net change, but it also brings to a close this video series on Calc 1. I hope you have enjoyed this series, and if you decide to watch any future videos, I will see you in the next one.